Today, desert ranchers and farmers have affordable restoration tools at hand in the form of keyline theory, the yeoman's plow, water harvesting techniques, and drone technology. These tools can help them escape the straitjacket of big agriculture's wasteful and destructive range practices. The correct way to restore desertified grasslands and their animal populations is applying these tools in the context of holistic thinking, embracing biodiversity as the driving force, and using Keyline and its associated technologies to jumpstart the process. Together, these practices, which poison no plants and kill no animals, offer effective, cheap, quick, economically and physiologically sustainable ways to increase soil fertility and soil's ability to absorb and store water. We can't make it rain, but we can make the rain that falls increasingly effective, which is practically the same thing. Presented as 3 rules which are based on our personal experience, here is how we use Keyline concepts to improve water function at our family's 32,000-acre Circle Ranch in the Chihuahuan high desert grasslands of far west Texas. The Keyline rules are followed by a discussion of water harvesting and the role of drones. Circle has been a working ranch since 1879. Since 2000, range and wildlife restoration has been our primary goal. Animal impact from wild and domestic animals is our main tool for change. While our grazing practices are not covered in this presentation, the land management practices I describe are unsustainable without them. Healthy water function is inseparable from the interaction of plants and animals. P.A. Yeomans was an Australian inventor and equipment manufacturer whose understanding of hydrology and equipment design grew from his work as a mining engineer and gold assayer. He developed Keyline theory and the yeoman's plow, a subsoiler with thin shanks and small, flat-running chisels. Keyline rule number 1: read the book. To apply Yeoman's methods, one must first understand them. Yeoman's best-known book, Water for Every Farm, was updated by his son Ken and is available through Amazon in paper or Kindle editions. By slowing, spreading, and holding water high on ridges and in valleys, Keyline encourages water to soak in as close as possible to where rain falls. Using plow patterns and spreader channels, runoff is slowed, spread, gathered, and respreads as it moves downhill. Keyline theory is a comprehensive approach to surface water management which includes ponds, irrigation channels, and windbreaks. Yeomans intended it for urban areas as well as ranches and farms. Worldwide, Keyline ideas have increasingly gained acceptance. They underlie many sustainable agriculture courses and are a key factor in permaculture design. The yeoman's plow is available in several models which P.A.'s son, Alan, manufactures in Australia. Various American vendors import the plow or its components for which they fabricate frames. I think of the yeoman's plow as an irrigation device designed to open soil to rainfall without harming plants. Most traditional plows are designed to turn soil over, to kill weeds and prepare a seedbed. This increases crop yields in the short term, but it harms organic material and soil life by exposure to the elements, sun, wind, and driving rain. Add in the repeated application of chemical fertilizers and pesticides, and the result is that soil loses its fertility, its ability to hold water, and its stability. This increases soil washing, erosion, flash flooding, and sedimentation. In contrast, Keyline opens soil surface to rain and loosens deeper soil without turning it over. More rain can enter soil and then spread out. The increased soil moisture detonates a physiological chain reaction which increases root depth, plant growth, soil fertility, and water retention. Other benefits include reduced storm runoff, erosion, and downstream sedimentation. Every ranch should own a yeoman's plow. We use ours a few days every week to subsoil degraded grassland that has regressed to brush and bare ground. In unplowable areas such as where there are ledges or rocks, animal impact can help by creating fertilized seed beds for plant growth. In our experience, a 12 to 15 foot plow hits the economic sweet spot for rangeland. It's cheaper. According to America's industrial agriculture mentality, a practice can't be effective unless it's big, costly, and chemical intensive. This is wrong. Less is more. A 12-foot yeoman's plow should cost in the high teens. Wider plows cost more per shank. Wider plows need more horsepower per shank. In our desert soil, a 12-foot plow needs about 7 horsepower per shank. A 30-foot plow will require double that or more according to Yeoman's Plow Company. We paid $5,000 for our tractor, an old 70 horsepower John Deere. After 10 years, we rebuilt it for $7,000. Big tractors can cost 6 figures. This is more tractor dollars per shank. So, counterintuitively, bigger costs more per acre. Don't buy seed pots. There is plenty of native seed in the ground. Don't use a roller. On open range, it will hang on obstacles. Buy coulters. These minimize grass damage. Smaller works better on rangeland. Our little plow, pulled by an old 70 horse tractor, can be easily maneuvered around trees, boulders, gullies, and other obstacles. Weight matters. Tires last longer when using smaller, lighter equipment. Big tractors and plows are meant for level fields. They can come apart on rough ground. One pass with our plow costs us about $10 per acre. This is the variable cost, ignoring purchase of tractor and plow. Variable costs include fuel, labor, replacing worn plow points, foam-filled tractor tires, and machine repairs divided by 20 acres per day. Don't seed, something will sprout, compliments of Mother Nature. Plow slowly. Breakage and downtime can cost more than labor. On our ranch, if we keyline 1,500 acres per year, we will be out of areas to treat in just a few years. If you have really big country, or if you're in a hurry, buy a second rig. Keyline rule number 2. Always set a contour. Setting a contour is so easy and yet often ignored. Incorrect contour plow patterns can accelerate water and start erosion. The speed and ease of setting contours was revolutionized by the laser transit. Using a laser transit, one person can set 1,000 feet in 30 minutes. Laser transits cost less than $500. Anyone who says he can eyeball a level contour from a tractor seat is mistaken. Even flatland undulates, alternating between what yeomans named valley and ridge shapes. It is often impossible to see whether contours are rising or falling. Nobody has the depth perception to see elevation changes of a few inches across hundreds of feet. Even if they could, the concentration required to do this for hours while operating machinery and dodging obstacles would be impossible. To use a laser transit to establish contours, set up the tripod with the laser transmitter. Walk out a few feet in front of the transmitter until the receiver beeps that it is at the same level as the transmitter. Place a fluorescent irrigation flag at that spot. Move away 50 more feet and find the same elevation again. The hand unit will beep to tell you to go up, down, or stay where you are. Keep doing this on 50-foot increments. Then do this in the other direction. Now you will have staked a line of alternating curves like linked horseshoes pointing up or down. Patterns are obvious when laid out over hundreds of feet as seen from above. If the horseshoe's open end points downhill, you're in a valley. If the horseshoe points uphill, you're on a ridge. Keyline rule number 3. Plow valleys down, plow ridges up. By down I mean place your next plow line below the last one. By up, I mean make the next plow pass above. The idea of keyline pattern plowing is to redirect water flow to keep water as high as possible in valleys and on ridges. Water wants to move at a 90-degree angle downward from wherever it is on the contour. Keyline slows this by trapping flows in the plow pattern. Within the pattern, water will appear to rise in a valley, but only because the pattern keeps it falling downhill along the valley wall more slowly than it would be moving downhill if it were following the valley bottom. The only plow line exactly on contour is the shank passing through the flags. Since contours constantly change, especially on valley sides compared to bottoms, every adjacent line will be off to some extent, and these errors accumulate with each successive pass of the plow. After a few hundred feet, the entire contour should be reset. If you are plowing a valley upwards, the cumulative contour error will tend to direct water towards the bottom of the valley. This is the opposite of what you want, so plow a valley downward. Plow the ridge upward for the same reasons, to hold water high. There will always be a pattern error. Water will tend to flow along the furrows in the direction they slope. Just make sure it tends to direct water upward relative to the shortest path downhill. If these ridges and valley shapes are not pronounced, treat the whole area as a valley and plow downhill. If the shapes are pronounced, then you will have to plow up on a ridge or down in a valley. Always follow the rule. Plow valley shapes down and ridge shapes up. Again, read the book, Water for Every Farm, to understand why. You cannot explain or evaluate that which you do not understand. Water harvesting and keyline. 11 inches of annual rainfall doesn't sound like much, but across 32,000 acres, that's about 10 billion gallons per year. Much of this runs off down roads and gullies. Permaculture planning incorporates methods of harvesting this water, moving to where keyline thinking begins. One of the leading practitioners of desert water recovery is Bill Zeedyke, who after 34 years of habitat management with the U.S. Forest Service moved to the private sector in Albuquerque. Bill teaches simple, low-tech methods to heal eroded streams, gullies, and roadbeds. Instead of viewing runoff as a liability, Bill treats all desert water as a precious asset. Bill uses gravity to direct runoff to reshape stream banks and rebuild floodplains along gullied stream channels and roads. Selected banks are intentionally eroded, which deposits materials on evolving floodplains, large and small. Rivers, gullies, and roadbeds self-heal as previously fast-moving water slows down and meanders. As vegetation recovers, it also helps slow the movement of water, accelerating the healing process. These techniques deserve close attention, but are not my subject here. I mention them because recovering runoff from gullies and roads is obviously inseparable from its redistribution using keyline techniques. Since we started using our yeoman's plow, a wonderful tool has emerged, the quadricopter drone with HD video recorder. There are misconceptions about drones. Let me start with disclaimers based on our experience at Circle Ranch. Drones are aircraft. Flying one takes time and skill. As computer systems improve, flying is getting easier, but the flight systems are still prone to glitches which cause the drones to fly off course. For this reason, the operator or his spotter must keep the drone in sight at all times. Drones can't be piloted by screen. Ambient light is usually too bright, and the operator can't watch the drone and the screen simultaneously. So useful observation comes from viewing footage post-flight. Drones are easy to crash or lose. Control systems of lighter drones are delicate, and a crashed drone may not work right after the incident. Crashing bigger drones with more payload and power can be catastrophic and expensive. The best drones are Chinese, meaning there is limited U.S. support for product advice, repairs, and maintenance. Makers can disappear overnight, taking the ability to acquire spare parts with them. Even with these limitations, which hopefully will be resolved with time and technology, drones are a powerful new tool for wildlife and habitat management. Drone photography lets you see things that are completely hidden at ground level. Here is a series of spreader dams put in 70 years ago to stop erosion. This series of photographs taken from a drone shows that every dam has failed. The failures are evident when viewed from above. Keyline is about improving water flow to solve water problems. If you cannot define the problem, you cannot fashion the solutions. In our experience, aerial photography is sometimes the only way to define what needs to be done and evaluate results. Drones can go to unreachable places like these and get perspectives that are impossible on foot because of challenging terrain and because some things are only apparent when viewed from above. Here are views of grasslands responding to Keyline subsoiling. Note that plant densities increase uphill. The Keyline response is obvious in this fence line contrast. Note the contrast with the neighbor. No reductionist study can describe, let alone convey, such useful management perspectives. The best choice is DJI's Inspire, which fully equipped is around $6,000. You can get a drone that will do a decent job for $1,500. This is the DJI Phantom. Drone technology is advancing rapidly. Drones are a big commitment of time and money, but also a fantastic tool. I would not be without one. I would like to acknowledge and thank the Quivira Coalition for its role in introducing many of these techniques and for allowing us to share our experience and results with you. While these are specific to Circle Ranch, they should work anywhere to some degree.